Our next talk is from Dolgert, who will talk about testing, which we are all very keen on. So over to you, Andrew. Thank you.
Thank you. Hi. This is going to be a talk about the packages that we use to test Julia. A lot of people have written packages to help us with the testing process. And when I say a lot of packages, what are you thinking in your head? Are you thinking 10? Are you thinking 100? Are you thinking 1,000? I went and did a survey of them because I was curious. And what I'm talking about here is the packages that we use in our test directory. Sometimes they're listed in your project.toml in the test directory if you're doing that version. Sometimes they're listed in the extras of your main project.toml. I went through and looked at all of those. And so I'm an academic, so I had review criteria, and I didn't want to give you my opinion. I wanted to go through everything that I could find. And so this is all tracked in my GitHub under juliatestdeps.jl. This talk itself is in the docs directory of that if you want to take a look. But I went through the 12,000 packages, 12,000 plus, as you've heard in so many of these talks on JuliaHub. I went through GitHub. I looked at the most recent packages on GitHub that match the word test. I had to match the word test because so many of them have no tests. But just to see how the trends are doing. The ones that I excluded, I put little notes every time I excluded something that was used in the test directory. That would be things that don't install under LTS 1.10. That's the criterion. Or things where, let's say you had a package that figured out the nail polish colors that sell the best. If you also have nail polish colors test, that's just for you, didn't count that one either. There are a lot of those. It's a super useful pattern that people use where they have a test package for their main package, but you're not on this list. If there are others that are missing here, let's try to pick them up at the end. I'll try to end in time. Oh, by the way, on JuliaHub, when I went to search for which testing packages were used the most, couldn't really find that. JuliaHub does the thing that you most want it to do, which is to show you the packages that are in the main dependencies of your packages, the ones that you care about when you install. The test packages don't really get marked, and so their popularity, their usage doesn't really get shown there. And so that's another reason that I went through this, just to figure out what's going on and who knows something about testing that I'd love to know. So I'm here from the Software Engineering Institute. That's why I've been sitting at a booth. I'm so happy that they sponsored this year. I'm in the AI division. We're down the street. We're part of CMU. And I myself have used Julia since forever, as far as Julia is concerned. Really love testing scientific code. I have 3 packages, one of which I will try not to talk too much about today. So the organization of this talk, I'm going to pretend that I'm a person who's testing. I'm going to pretend that I'm a person who's really stodgy about it. The way that the International Software Testing Qualifications Board talks about testing. We don't often think of it this way, but you choose your system under test, then you generate test cases. You could generate a lot of them, and then you select a subset of those test cases. You decide how you want to run them, and then you report on them. I know that this isn't how you work for test-driven development, but it is a way to organize this talk as though we're walking through that today. So, first of all, there's a lot that happens in tests that isn't testing. And we're not going to count these as testing, I guess, but it doesn't matter. So the test directory is a great place to use your package for things that you need to do with your package. And so people build their packages with package compiler in test, as an example. They write documentation or papers in their test directories. It turns out, I'm just looking through what people have done. A lot of people do test-driven development, of course. And so their revise is often used in your test directory, but also one that I didn't know about called Infiltrator that will let you drop into a live debugger. Super helpful if you're running a test case, you see a problem, you want to debug it. Infiltrator is something where you put a little note in there, a little macro, and then it'll drop you into the debugger the next time you run. Oh, I'm not going to discuss every bullet because I don't want to go too quickly. And so these things are all there later if you want to see the PDF. The next question, what's our system under test, right? And so you should test all the things. Everything you show your user, you're going to test in some way, or you can, at least, given all the help that you have from the people who have written these packages. So docinventories.jl is one way to test the documentation. But of course, benchmarking happens a lot in your test directories. Your benchmarks are not functional tests. That's the tester's word for testing if it's correct. But benchmarking is the way that you determine if it's fast enough. And the most used benchmark tool from the survey that I did is benchmark tools. The most recent benchmarking tool is chair marks, and I've seen that used in a couple of these this week. Alloc check is one that I didn't know about. It'll check that your function does or doesn't allocate memory when it gets called. And if you're hoping to write a function that's efficient in Julia, often you're trying not to allocate memory. I didn't know that existed. It's one of the surprises of the day. A bunch of the tests are testing the package itself or how you've made the package. As we know, this can be a somewhat delicate process in Julia sometimes. You can write a function that overwrites a function in something that you used without actually let's say you need to import base to use base.getIndex. There are packages that test things like this. The most popular of them is Aqua. When you create new packages, there's an option to install Aqua. It's nice. It catches a lot of things that would normally be caught later, such as your compatibility indexes on GitHub. If you use Aqua as a local test, then you won't have those compat problems later on GitHub. So much so that compat helper is no longer really going to catch anything on your code. Jet.jl does similar tests. It's a little more in-depth and used less frequently, but used by some of the largest projects. And, if you're new to Julia especially, interactive utils and stdlib contains a whole bunch of macros that will catch things about your code by using macros like @which looks for method names that take certain arguments. Take a look at what's in interactive utils if you are new to Julia and trying to figure out how to test a package. It's built in, but super helpful. Again, we're choosing the system under test. 3 interesting packages in Julia will test systems under test that are not library function calls. I find them very interesting. One will record HTTP traffic and play it back. That is the most used of these. The 2 others will test the GUI and test a terminal user interface, as though you are the user. So the GUI one will click on your graphical user interface if you happen to be using IMGUI. The terminal UI will send character keystrokes to your terminal application. These are super inventive and great ways to do testing. This keeps going on finding the tests. There's a lot of different ways to find tests. So if you offer a README to the users, which we all do, might as well test the code in the README. Might as well test the code in the documentation with the doc tests. If you are showing a notebook to your user, there is Pluto test and NB include to test those notebooks. It all makes sense. When you do your tests, you often need to download files, and you have that moment. I don't want to check this into GitHub, okay, but I do need to get to the file. How do I do that? The ways that people solve this problem are varied. These are most of the most common packages that are used in your test directory when they aren't also used in your main dependencies. A lot of people use downloads. That's the most popular one. Downloads is sort of that one function package that has download. Really straightforward. The newest one on this list that I want to call out is datadeps, which tries to be more specific about the identity and the hash of the thing that you're downloading. So that's super useful. But people will use AWS, Google Drive, any way they can get to the thing they need to get to in order to use a file for their testing. And they use any kind of file format. This is actually not all of them, but it's just a panoply. In other languages, you might think a lot about fixtures for testing and how we use fixtures. Julia has one main mocking class that gets used. I understand it's going to be of more use in 1.12 when the world age is working nicely. And so mocking is a tool that will let you pick your function that you want to test and test that single function more specifically and less the collaborators of that function by swapping out some of the other functions that it might call. The next line is about ways to capture standard error and standard out. Have you guys ever heard, there's a paper on how to make functions testable, and it has principles that are SOX to make it simple, observable, controllable, and knowable. It's not a really well-known acronym, is it? SOC. But if you can't observe what's going on in your package, you can emit text with @debug, and then catch it with suppressor or IO capture, and then use that in your test cases. Similarly, there are other useful fixtures like Scratch, where you can write temporary files, they'll be deleted, or .env, where you can load environment variables if your code is interacting with the environment. So you can try lots of different environments. Two different kinds of tests. We're now in the test case generation part. I find this part really important. I think in a world where we're working with LLMs, they can, in their best usage, can reduce the burden, the barrier to using more complicated things that are also more powerful for us. Property-based testing is an example of a powerful way to generate a lot of tests that are going to be more effective, especially if you're talking about lower level functions in your system. Property-based testing is going to take the arguments to your function. You give it the types of that argument, maybe a little more information, and it will generate tests that are most likely to find corner cases in your function. That's the idea. Of these three, there's prop check, randomized property test. I think supposition has the sort of the longest, most thorough documentation. And there's an example here. Property-based testing is a real boon to have in the environment. So combinatorial testing is another kind of test case generation. The easiest form of combinatorial test case generation is right there in the regular package test, the default package test. So if you write a test set, you can write a for loop when you generate that test set, and it will create, 1,000 tests in your for loop with 1,000 different arguments. Here in this example, there's a v in itrv. We're assuming itrv is some iterator over v. It'll generate a separate test for each of the v's and each of the w's. Unit test design, that's mine, so I won't talk about it too much, but it is a way to write tests for that top level of your application. So at the top level of your application, you have a whole bunch of options often, you have a whole bunch of arguments effectively. If you want to choose a few of each argument and then try to generate test cases that best cover all the possible options within as few cases as possible because it runs for a long time. That's what unit test design is for. It does in all pairs in this case, but it does other things. The branch tests, I had never seen before. I thought it was odd when I first saw it. It's a way that you create a normal test case, and then it's hierarchical. We often make hierarchical test cases, right? You nest them. In this case, when you nest the test cases, that forms a little tree. It will generate a separate test for every way to walk down that tree. It wasn't something that I knew I needed, but it's kind of fun to find. All right, testing scientific code. Most of what we do when we write scientific code is we write things where we don't know the answer, but they're often comparable to other things that are similar or other code that writes similar answers, right? How do you make tests that test scientific code? It's this parabola. It's a testing by comparison. So these get used a lot. So R call, Python call, people keep the R code in their test suite. They keep the Python code there because then their code gets compared to the code that it was originally copied from. Maybe yours is always higher or lower. That kind of trait gets tested. And there is a bunch of use of types in tests that are not the types necessary for the package. Let me explain. Let's say you write a package and it works for abstract matrix. You know that it worked in your trial for a dense abstract matrix. Well, you can put in strided matrices, sparse matrices, all the different kinds of matrices in order to do a comparison there. You can run symbolic versions through, thanks to Julia's interoperability, and use those to do your test cases. So there's a lot of kind of the weird and wild versions of containers that get used in test cases. Of course, people want their assertions to be as descriptive as possible, and it's not sort of hard to work on these. There's a whole little plethora of different ways to improve your assertions. Safe test sets, for those who don't know, gets used a lot. A safe test set takes your test and it puts it into a little module. And when it's in a little module, because of scope, it is a little safer from polluting the world and being affected by the rest of the world. At inferred from base is used a lot in tests. I'm saying this for the new Julia users. We talk a lot about type stability. The way that you make sure that you've managed to get type stability, at least maybe not sure, but you can test whether you have type stability, is to use at inferred in your test sets. It gets used quite a bit. And remember, at inferred, it will return its values, so people use it quite liberally. They just pepper their test code with at inferred. There are a bunch of tools here that will make your diffs better, so that if at the moment you do your at test, you say, is A equal to B? It will tell you exactly why A is not equal to B. Deep diffs, struct equality, both do that kind of thing. The other one that I'll call out here is uniful. You may think, okay, this gets used in test sets, and here's why. If you've written a function and it's meant to be science, it's meant to be chemistry, physics, whatever it is, and it's doing a calculation, if you use uniful, you attach units to that test, and your output should have the correct units. If your output doesn't have the correct units, that's a good sign you did the wrong thing. I'm a physicist, I'm sure of this, but in the testing world, they call this metamorphic testing. They give it a really big name. It means if you scale A bigger, B should scale down, whatever. Uniful is a great thing to use in your tests. All right, we have a few minutes. We're going to talk about the frameworks and then how you judge whether test cases are good or not. So test.jl. All of the packages that are frameworks that try to replace test.jl talk about two things they're going to do for you. These are the two things. One, they talk about that they're going to be able to find tests in your test suite and then not run them immediately, but store them so that they can change the order of what's run, filter what's run them in parallel. They also talk about being able to test code that isn't in the test directory. These are the two features that most of the test frameworks that try to replace test.jl talk about. Of course, we know test.jl works for 99% of the things that you want to do in your testing. There are a bunch of test frameworks that don't load on 1.10. And I just want to salute these folks. I've used a bunch of these over the years. I really appreciate this work. Right now, you may be a person who likes having control over all the parts of your environment. There are tiny test frameworks that are just for you. I'll call out Pukeko, which is the name of a bird, apparently, and they have a photo of it. Just for that, it's worth seeing. It'll give you parallel test execution without doing a lot else, and maybe that's what you're looking for. As well, TidyTest doesn't actually provide its own framework. It's a new subclass of the test set, which is an abstract base. TidyTest will let you do test selection using the regular test. Both small, nice additions. Here are the 4 big test frameworks. And I went and looked at how popular they are. So test items, test item runner, retest items, these are all associated with the Visual Studio Code plugin. These are really growing in popularity very quickly. Retest, XUnit, and Jute all have really similar claims to what features they do. Retest is the most used of them. They do that thing. They collect your tests, they select your tests, they run them in parallel. And they focus more on how hard is it to run my tests? How hard is it to filter and select them? Test item starts from this one big move. It says, we know that the code that is in your package is costly in Julia, right? You don't want to put tests in with your package because they need to get JITted, they need to get installed. Test items makes a macro for your tests. Tests always seem to use macros, but they make a macro for your tests that go in your package. By default, that macro evaluates to nothing, just the word nothing. And test items, when it goes to run your test, grabs them, compiles them, and then runs them. But by default, they don't pollute the test base. That's the big move around test items. And I'll say in all of these, there's inventiveness. XUnit, retest, Jute, test items all have some nice moves in there. There are a couple of tools to run unit tests. I'll mention I of raw because it's nuts. It will run your unit tests continuously. Just keep running them in the corner. It's a wild idea. Test Picker got mentioned this week as a REPL mode. Excellent idea. There's also a CLI. for running tests, also an excellent idea. For seeing test case output, the Visual Studio plugin shows you what you see above. This is for one of my packages. There's definitely a hit when you see everything go green. It's really pleasing. It's worth writing more tests just to see more green lights, I think. But there are other things that provide other kinds of outputs. This, I also think, so I called out test case generation. I also think the test quality is important. And the more that we aren't writing our own tests, if that happens, the more that understanding the test quality matters. Julia always almost seems to measure your line coverage for lines of Julia. Oh, more than I thought. And your local coverage is a version of getting that coverage locally. Now, I've talked with a bunch of people who wanted to get coverage, line coverage that was more, where they could get line coverage for an individual function, or they had a mono repo with a bunch of packages in it, and they wanted to do separate coverage for the mono repo. I know that it's possible to sort of hack the coverage mechanism in order to get better coverage. Right now, coverage and local coverage are the two most often used things that we have. Julia had, probably 7 years ago, something called VIMES, which did mutation coverage. You may not have heard of this. It is the gold standard. It's not perfect, but it's still a gold standard for the testing community to evaluate the quality of your test suite. What it does is this. You have a test suite, you have your code, it makes a copy of the code, and then it finds a spot by random, and then it breaks it. Then it runs your test suite and sees if the broken spot was found. And then it fixes that, goes to the next one, breaks the next one. And so it just does that repeatedly, goes into the syntax, usually use it sort of a syntactic understanding of the code, breaks it over and over again. And VIMES did this. It doesn't run on LTS 110. I don't really know the state of it. But the story is that by the time you're done with this, you know the percentage of broken tests that were found. The problem with this is that when a test is broken, it might not really have been broken. They might have added a +1 to a loop index where that loop index was never really exercised anyway for another reason. There was always a break or something like that. So even so, the mutation testing is an interesting sort of gold standard. In addition, there are other kinds of coverage that we don't have. You can have branch coverage. You can have path coverage, function coverage, modified condition. Decision coverage is sort of the nutty NASA level standard. But there are other ways to do test quality that I think are becoming more important over time. So the end is, when I look at this, I think, what would I love to have, right? There were 70 to 80 packages I talked about there. There's a lot of effort that goes into making testing better, of higher quality, which I really appreciate. I'll note that one of the things that I've used in Python, was a way to measure test coverage per test. In our case, I guess we call it per test item. You figure out which parts of the code get exercised. When that piece of code is exercised, only the relevant tests get run again, which can really speed up your test case runs. And that's, in order to do that, you need test selection. You need a little bit of memory in your test environment. You need a number of things that we don't generally use. And another is randomized tests. There are no packages that help randomized testing. There's work in the frameworks. Specifically, I think there was a recent work in test.jl to make randomized testing work better. But there's sort of no packages to help make tests. For instance, for scientific coding, it can be super helpful to ask, when you ask not just is A equal to B, but how can I optimize the arguments to a test such that A is as far away from B as possible. That's the kind of thing that helps with scientific code. It's an optimization problem. It looks a lot like probabilistic programming. But if you have other ideas, I'm open. Or if I missed anything, open to that too. That's it.
Thank you. We have time for a couple of questions. Rachel?
Cool, thanks, Drew. Real tour de force here. I'm curious, maybe it's in the repo. Do you also have like stats collated on all these things you went over in terms of like how often different things are used and all of that?
For myself, I rank them 1, 2, 3, 4, 5 but I don't have the percentage of times they're used. Even, it would be nice to know the percentage of packages that do or don't test at all. Just where are we sitting? But I don't know what to compare that against, right? If I go to the Java world, how often do they test? I have no clue. And do I care how the Java world tests?
Okay, there's a question here.
Like, very good piece of work. I truly appreciate. Like, I'm wondering, like, I suspect that many testing framework will be used at the same times. And do you have like some feeling about that?
Are you asking whether the test frameworks get used at the same time?
Yeah, I mean, I would guess so, but you know, like for one application, they will use not just one, but several testing framework. You know, and they may I mean, in our code base, at some point we were using relint and we were, retest, and we were using the XUnit at the same time. And
you're right. You can write your tests such that multiple frameworks can be used to run the same set of tests. And I haven't looked for that. That's a really good question. Because it's a great way to go from one testing framework to another. Or, look, the mindset, I think, in the Julia world doesn't even include things like, what if I'm running several processes, and I don't just want to, you would want a separate framework, essentially, to test different capabilities of your code. I haven't looked. It's a great question.
So regarding for the test selection thing, I actually wrote a new package named testrunner.jl, which exactly does that and allows you to run per test case execution of test code. So yeah, it only works on 1.12, but you may want to try it.
It's called, you said testrunner.jl?
Testrunner.jl. It's not published yet.
Okay, good. But no, this is the right time. That's perfect.
Okay, thank you, Drew. A round of applause for our speaker, please. Thank you.